Alright, grab yourself some marshmallows and fire, I don't know. It's story time. A million years ago, I was working on a project and thought I could find help with a few translation tasks through a pen pal website. Back then, I had really long hair and didn't know sites like these were being used as data foreigner services, so I got a fair share of unsolicited messages. One day, I got a rather peculiar message in the rubbish. The sender was going by CC on the site. Not that one. She was using her initials as a pseudonym, and was apparently a biology major from Poland. I felt her attitude was a bit too clever for some random person I met on the internet, so as any reasonable person would do, I tried to show her up by challenging her to puzzles. She solved everything I sent, each in under half an hour, so I sent her an A3. You can judge for yourself how hard those are. And of course, she solved that in an hour, while riding the bus home. I was confronted with a dilemma: face reality and take the L, or give her a completely unsensible puzzle from a topic she probably wouldn't know. The puzzle went like this. What's the best algorithm you can find when given a list of numbers returns a list where each index holds the sum of all the numbers up to it? Unfortunately, she had no idea what best even meant, so I ended up having to explain work and span. I sat back in my chair and mentally congratulated myself for stumping her. But nope, the very next day, she told me she solved the puzzle. First, separate the input list into sublists of size log n. Next, iteratively compute the prefix sums for each log n sublist in parallel. This takes linear work and logarithmic span. Then, form a new list of size n over log n from the last entries of each sublist. We'll next operate on this new list using a separate algorithm based on your hint. This separate algorithm will take a list, break it in half, recursively compute the prefix sums of each half in parallel, add the last entry from the left half's recursive result to all entries of the right half's recursive result in parallel, and return the concatenation of these two. After running this separate algorithm on our new list, we have its prefix sums. The separate algorithm recurses log times with linear work and constant span each level, so on a size m input, we do m log m work and log m span. But since our new list was only size n over log n, running the separate algorithm on it takes log n span and n over log n times log of n over log n work, which is linear when simplified. Finally, to each entry of each sublist, we add the value from what we just computed corresponding to the sublist before it in parallel, and we're done. This last part takes linear work and constant span, so in total this process takes linear work and log n span, which was the best I could do. What was your solution? She achieved the best asymptotic bounds. I fumbled out the algorithm I heard in lecture, which you can read on Wikipedia. It uses something sometimes called concatenation, and was definitely not the algorithm CC found. Anyways, I've never since questioned her problem-solving ability, and have consistently made attempts to sell her on leaving biology to become a computer scientist, often to her irritation. I guess the moral of the story is, don't be an asshole, but if you must, try to make something cool out of taking the L. To this day, I'm still not sure if anyone else has thought of her solution.